Okay, so basically, we had like very kind of, I should say, simple explanation about having a balloon and then press it. When we are pressing that balloon, in the eyes of observer, I have two balloons in hand. One balloon on right side of my hand and another balloon on left side of my hand. This is what observer sees. But actually, this is one balloon. In the eyes of observer, it sees two balloons. On the right side, attached to the right side and left side of it. If I collapse this balloon by, for example, nail or something, both balloons will collapse. This is the right definition of Fabrika. Fabrika can be, for example, can have a shape which seems to be in two places at the same time, like place of the observer. But actually that is addressing one place in the space and time.
But still, perturbation needs time to go from one part to other.
Actually, that is the same place. So there is no time it's gonna be passed if you want to move from this balloon to this balloon. It is the same place.
But in real balloon, it needs
yes,
time.
For sure. In real balloon, yes, but
for
it's
perturbation too. Yeah.
Exactly.
It's a huge velocity, of course, sound velocity.
Yeah, sure. But that is just a very, like rough explanation of what we are talking about Fabrika. Fabrika is addressing the place and time and reality by itself. It's not an item, it's not a particle, it's not an object, it's not even an element. It is space, time, and reality at the same time. Now, let me actually clear more about what we are doing here, about space and time, because it is extremely important to clarify that. Now, basically, in general relativity and special relativity, we have this. Usually it is like that, right? We are talking about t, and then we are talking about x. Usually, when we are talking about movement or we are talking about anything that is related to special relativity or general relativity, we have this. Now, in this theory, in Fabrika theory, the framework itself is quantized. What that means, instead of this, we have this.
Fabrikas.
Yes.
So space-time.
X, t for sure, r, and also we have xt, 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 xt.
Discrete space-time.
Yes. And each framework acts separately. What that means, if, for example, we remove this framework, suddenly, what will happen? We will have time dilation. This is exactly what is happening in gravity as we define a subtraction of Fabrikas. Therefore, something will start to collapse in in the subtraction of the Fabrikas. And when something is collapsed, the calculation will be way easier because we don't have one x and we don't have one t. We have unlimited, not unlimited, but a number of x and t's acting separately. Now, let's say if we are talking about a wave. This is extremely important. In wave, in quantum physics, it's a particle which is waving, correct? Mm-hmm. That is a particle and acts as a wave. In this, we have a framework, a connected, basically Fabrikas, a set of connected Fabrikas that we call Barba system, that they are connected together, created a bigger, like we use bigger with care, but anyway, a larger framework.
Subspace.
Yes, exactly. We can call it subspace. but for sure it's larger than Fabrika's, each Fabrika alone. And then that framework is waving. The whole framework, X and T, everything is waving and particle is here. So basically we have a larger subspace. This is a good word, actually, I like it, it's cool. We have a larger subspace, connected Fabrikas together and representing a particle in that space. Now, this is exactly how we can address double slit experiment. And because it has reality dimension, as soon as this reality dimension connects to another reality dimension of observer, this system will collapse. Because one of the dimensions are forcing this system collapse, and therefore this particle will lose the subspace, or for example, we lose the Barba system that it was in, and it end up in basically one place. And yes, as a particle. So that is the X and T and R that are actually waving. It's not the particle that is waving. And that's how we can address the whole problem of entanglement, the whole issue of double slit experiment with quantum eraser, which quantum physics doesn't have any answer, none. But we can actually clearly address this when we say that is actually X and T and R, like dimensions of Fabrikas that are waving, not electron. And this will question the Copenhagen interpretation completely, and for sure uncertainty, we address uncertainty in a different way. And all of the predictions of quantum physics will be addressable by this as well, because we just move the equation to the other side. Rather than setting X and then consider particle to be in a superposition in several places at the same time, actually infinite places at the same time. This is what quantum mechanics say, that it says one particle exists at multiple places at the same time, and we can actually say no, that is not multiple places at the same time. It's the same place, and the place itself waving.
Extending place.
Exactly. Like they extended this Barba system. We call it Barba because it has a very good cartoon explaining what we mean, like back in 1970. And we call it Barba system from now. Barba system is a system that basically Fabrikas handshaken Fabrikas, they are representing the same particle. They are representing the same event. They are representing the same time. This is also extremely important. This Barba system, when it's handshaking, is representing the same time. What that means? That means if a particle started 1 million light year ago, like a wave, 1 million year ago and 1 million light years away. Why, when it's coming here and we have observer here, it ends up as a particle, not wave? Because the observer here collapsed the whole Barba system.
So Barba is lost and the particle is left.
With the representation of that time there and this time here.
Connection is left.
Exactly, because it's the same place and same time. Basically, when we see the particle here, that Barba system represents that time in the past, and this time now here, that time is the past away, and this time now and here in the same system. So it's the same framework, same system, same place and time. So that's why actually in the start of the videos I used this phrase. Long time ago, a galaxy far away, that is actually here in this system. And that's how we can understand how the particle understood, which is a very stupid word, how the particle understood that should start as a particle. No, we collapse the system by imposing the reality to this. So basically we collapse it. If we can also collapse it by basically, again, trying to force the particle to move, to basically change change the system, and this system will collapse pretty fast, not fast, immediately.
What I think, this particle is a matter, right?
Yes.
And then it looks like from these fabricas, some matter is left when we collapse it.
Yes, the same matter.
So matter is created from space, Barpa space. From
yes, if we actually put this, look, we can actually give one matter right now. For example, let's say this matter is now
mass
is here and just not moving. As soon as we start giving it energy and vibration, it will create a Barpa system. That's how actually different fields getting created. And different fields, there are different Barpa systems with different type of, for example, shapes. And then, as soon as we have this
measured,
this Barpa system will collapse. Again, end up in the minimum number of Barpas that it can actually take or have. So basically, the moment that we give the vibration to the particle,
measure
that the basically or energy or basically velocity, and it starts making the waves. The more energy it has, the wave also wavelength will change. What will happen is that this creates a Barpa system according to its situation and basically characteristics.
New situation, new
Barpa system.
New subspace.
Yes.
All this destroyed.
Exactly, based on this. And as soon as we collapse it, for example, we take the energy away, this will collapse. The Barpa system will collapse. It will end up, will get lost. Now, the Barpa systems also can affect each other. Their color can get, we call it color, or basically their properties can actually collapse each other, or they can integrate into each other. For example, let's say if you have two waves, two Barpa systems, one has a certain wavelength, the Barpa system itself, the framework itself, X and T, and then you mix it with the other Barpa system. This framework will change. Still, the particles are same, and because the framework is changing, everything basically will be based on the new integrated wave. That is how we address why the light is slower in the glass. This is, again, same equation. So what happens in the glass? We have a different Barpa system for the electrons, like around the atom, or the situation of the system. This framework of the light in the vacuum will get mixed with the framework of the glass.
Framework,
subatomic particles.
Do you mean coordinate system or environment?
It has the T also. Yes, coordinate and also
environment.
T.
Medium.
Yes. The whole Barpa system of that glass will get mixed with the Barpa system of the light.
Particle.
Now what will happen? This will affect that framework as long as it is mixed. The light will be slower. You know how many times it will be slower, like 1,000 times it will be slower. And then as soon as the light goes out of the glass, what will happen? Immediately the light will gain back the speed immediately, because the Barpa system gets mixed with another Barpa system, integrated, and again split it. And now it's coming. So that's how T of this light got mixed with the T of the basically glass. Yes, the framework of the glass. Basically the Barpa systems in the framework of the glass, around atoms or. And this is how we can address double slit experiment with the quantum rays. Because in there, what we have is this.
Yeah, difficult part is interaction of the, or to playing together of matter and then space. At what moment matter is created.
Mm-hmm.
It's
Okay.
like, observation is like creation.
Observation is like collapsing the Barber system.
Collapsing Barber.
Why? Because when we observe, look, we define Barber system with 5 dimensions at least. I will tell you why I said at least. Okay? Basically, we have X, we have Y, we have Z, we have Z1, we have T, and we have R. Now, basically, the reality of things, when we observe something, we are imposing the reality. Therefore, it is like imposing X and Z to electrons. So basically, if you want to stop an electron, what will happen? You collapse the system immediately. If you stop the electron, you will collapse it. You will collapse the system. So basically, if you impose X, Z, Z1, T, or R, this Barber system will collapse. So stopping an electron is exactly imposing X, Z, and Y, right? We want to stop it. Therefore, we impose something, we impose the location.
Even if it's not stopped and measured.
Yes.
You can say that I measured at that moment.
Now, the measurement basically it is also because that is a problem with double slit experiment with quantum eraser. Now, when you impose the reality, you will change something in the past. How that happens? In Barber system, when you impose a reality, doesn't matter because these are representing, this Barber system representing same time, exact time, and space. And reality.
This was the Copenhagen interpretation in the Schrodinger's cat experiment. There are several different interpretations of quantum physics that exist today.